podcasts you love.
From people you trust.
This is TWiT.
This is TWiT event number 1 for Saturday, November 30th, 2019. Introducing Squirrel. Are you ready? Let's do it. Hey, everybody. Welcome. It's good to see you. Squirrel Reveal with Steve Gibson. We've been waiting for this for 5 years, believe it or not. Steve is this is going to be a TWiT special. He's going to go into great technical depth about how Squirrel works. We're going to show it working. Steve is here. Don't worry. I'm not going to do it. Steve, because I have no idea. But we're really excited to be able to do this for you. This is a very special. Steve's been doing this. He's already been on his world tour to Dublin and to Denmark and various other countries to show this off. Of course, all over the U.S. and Orange County, too. But for the first time, we're going to do it right here on our TWiT studio. So we're very excited. Ladies and gentlemen, for the moment you've all been waiting for, Mr. Steve Tiberius Gibson.
So, first of all, a big thank you to Leo and TWiT Studios for and now LastPass Studios for making this opportunity available, and to all you guys for coming out. There are people literally from around the world. I'm embarrassed about that, but thank you. So you guys are Security Now listeners. You know when this happened about, I think it was, where are we? It's end of 2019. So like almost now 6 years ago. It was in the late summer, and I'll explain a little of the details of this. I was having breakfast by myself, working on SpinRite 6.1, when this thing clicked for me in my head as a consequence of the fact that I'd been talking to you all every week for, at that point, half of the podcast's life, about 6 years. And the result is Squirrel, which is finished. It exists. There are clients for all of the various platforms, a browser plugin extension. GitHub has a bunch of source code for both the server side and the client side pieces. And so my goal here today, I wanted to sort of take this time, this sort of like the final, putting the frosting on this, before, yes, getting back to SpinRite 6.1, to explain what Squirrel is, why I think it can be explained as a simple system, which is also no simpler than it could possibly be. That is, it is as simple as it is possible to make it while solving the problems that I set out to solve. And of course, as all of us Security Now listeners know, what we have done to the world with authentication is a mess. I mean, we're techies. We should have done better than we have so far. We have pushed the dysfunction of remote networked authentication out onto, our friends, and we call them friends, and family and grandparents, and they're like, oh, no, Grandma, you can't use Uncle Bernie's name. You have to do something else. And well, why? Well, because, his name is Joe. And that's just, someone could guess that. They know Joe, they know Uncle Bernie's name? No, Grandma, but trust me, you have to do something different. But my point is, and then it's like, oh, wait, you got a really complex password, but now you can't use that. That's like your password, and you've been using it for years. Now, oh, you have to use a different one everywhere you go. What? How am I going to do that? How am I going to remember that? I mean, this is a catastrophe. When you think about it, it's a disaster. And I was talking to someone a few months ago, and as sometimes comes up in the conversation, that this is what I've been working on for a while, and I sort of tease them with, well, yeah, I've solved this problem of usernames and passwords. And they go, what? And I say, yeah, we don't have to have those anymore. And And they said, whoa. And I said, yeah, it took 6 years. And they say, oh, I solved it a while ago. And I said, whoa, what? You solved it? They said, yeah. You know, when they want me to like log in and create an account, I just bang on the keyboard for a while until that space fills up. I go, okay. And they say, and then I just log in. And I said, well, so you have a password manager that is like remembering what you did and it stores it for you so it can do it again? They go, no, no, no. And they said, I just don't, you know. I said, would you write it down? How do you remember it? No, none of that. She said, because when you want to come back and you want to get back in, there's always this thing at the bottom that says, I forgot my password. And it's true because I never knew it. So I click that and I get a piece of email and I get logged right in. Problem solved. And I said, okay, well, now this is really that's not a secure solution. That's not the way you want to be doing this. So we've driven people to the need for another tool to solve their memory problem or to just bypass all security, essentially all security, in order to allow themselves to get back in. We've abused the world. One of the things that I realized as I was sort of understanding where we got to with Squirrel is that when I was at Berkeley 40 years ago, in the engineering building had a Hazeltine CRT dumb terminal, and it was dumb. It's, you know, that's the term for those. It was just a screen and a keyboard, and there was no processor or anything. And you typed keys, and they went to a big mainframe in the back somewhere, some other building, and then eventually those characters you typed echoed onto the screen, and then you could go from there. So when I was logging in with credentials, I used, surprise, a username and password 40 years ago. So it's also crazy that nothing has changed. We're still doing that. Yes, thank God we have LastPass to remember these rules and the mess that we have made of this, but it's still what we're doing. So, and that should be an embarrassment to us. The key, though, one of the things that I realized is that what has changed in these 4 decades is that no one, not one of us in this room, ever logs in to a remote computer with a dumb terminal. Hazeltine, Lear Sigler, and all the rest, they're long since gone. We don't use those any longer. Everyone is logging in to a computer with a computer, which means what we're using it for now is, with LastPass, a store of all of our usernames and passwords. But the thing that is different is that this computer we're logging in with can compute stuff. It has computational ability beyond ours. We have maybe some memory, but we can't do fancy crypto math. But the smartphone we're holding or the desktop computer that we're in front of can. So that was part of this sort of the aha was, let's use the fact that nobody is any longer logging in with a dumb terminal. We're logging in with something smart. So what happened was, and it did begin with my original inspiration, because back then we were looking at multi-factor. This is 6 years ago, talking about multi-factor authentication and the idea of the YubiKey or maybe the smartphone as your authenticator. So the Squirrel originally stood for Secure QR Code Login. And as I began to develop this, I realized, oh, it's more than that. Because, for example, and I'll show you, with a client, with a Squirrel client in the laptop, there's no QR code involved. You just click on, I want to log in here, and you're done. So it became secure, quick, reliable login. Fortunately, we were able to come up with some other words that worked. Open intellectual property, unencumbered. I think you will find it easily explained. We'll take a vote at the end. This was also post-Snowden. And of course, we had a lot of fun with Edward Snowden and the NSA and all that. But the sense was in this, once we actually knew for sure that the NSA was listening, it wasn't just theoretical, then the concern was, okay, maybe there just isn't a way to do trusted third party. Maybe trusted third party is an oxymoron because, you know, if you tell somebody a secret, it's not a secret anymore. So this also was two-party. It's between you and the site you want to log into, no middleman, no third party. With that comes some challenges because there is no link for I forgot my password. There's no one to run to if you get yourself in trouble. So the reason this took years was I had to solve all these other problems associated with how do you actually solve the problem of truly secure two-party login, because malware could get in, bad guys, you could lose your device at the border who takes it behind a screen and you don't know what's happened now. You don't trust your Squirrel identity that was in your phone. So lots of problems to solve. You guys have a sense for the experience, but it impresses me even these days. I'm surprised by the experience I have when I log in. And hopefully I will have succeeded in this whole presentation if you end up wanting this to happen, to succeed in the world as much as I do. So let me show you what it looks like to actually use the system. So this happens to be a demo login site, and I can, as I mentioned, this laptop has the Windows client for Squirrel built in. So I'm able to click Sign In with Squirrel. And now this is interesting because, you know, I talk about how this eliminates usernames and passwords. Oh, wait, there's a password. Well, yes. Essentially, the way you can think of Squirrel is that Squirrel is a proxy for you, for your identity. So as Squirrel succeeds, Squirrel stands in for us. It provides a much more secure alternative to usernames and passwords. But somebody else could have walked over here and clicked Login with Squirrel on my computer, because my Squirrel client doesn't know it's me. So I still do need to authenticate myself to the Squirrel client. So I enter my super fancy password. This is deliberately taking a while. We'll talk about that in a second. And oh, the login page is expired. So that's true. It had been sitting there for the last couple hours. So let me try again. Oh, and this is interesting. I typed the whole long password the first time. One of the other things I had endeavored to do is I don't want this to be annoying. And so I realized there's a difference between this is me and this is still me. So the test for this is still me can be weaker than the test for this is me. So it's still me, bing, 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 and we use what we call the quick code. When I type in the entire password, after that validates, the client quickly takes n number of the first characters of that password, and you can adjust it. It defaults to 4, and re-encrypts the identity with that and keeping it only in RAM. So until something happens, until some time expires, until the screensaver kicks in, until I change users, and again, there are settings in the client that allow you to decide what events you want to have it forget the so-called quick pass, in which case you have to type the whole thing in. And it's intolerant. You make one mistake, first thing it does is it wipes out the RAM-based ability to do 4 characters and requires you to type the whole thing in again. So it's again, a sort of a carefully juggled trade-off. But I did that, and I'm logged in as Steve Gibson to the demo site, and I'll log out. Now, she was all surprised because, and this was the demo, the Gee Whiz demo. There's a little Squirrel logo there, a Squirrel client for iOS, and so it says scan Squirrel QR code. So I tap that, I let it see the QR code. Now I smile at it, hello, and I'm logged in. So didn't have to touch the computer. This was my favorite example from a very early presentation I made of Squirrel in Las Vegas at the DigiCert conference, because I wanted to get my boarding pass in the business center. and there were some computers there, and it was like, oh my God, I don't want to log into Southwest on this computer. You know, the keystroke loggers have keystroke loggers, and so I thought, you know, no. So with this system, I didn't touch the keyboard, so you could log in, and then we were just talking earlier about the idea of logging into a Netflix account in a hotel. Same sort of system. You certainly don't want to give any system there your username and password, you know, where you're away from home. You have no control over what's going on. I have the other example here that's fun is the Squirrel Forums, which exist, which are an active community of people. We've got, what, 3,238 members, 7,700 messages, a bunch of stuff going on. And we have places for, here's Jeff Arthur's Squirrel server. Jeff also has the iOS client that I just used. We have a GitHub, has a live Squirrel. We've got a Java library, a PHP library. There's a WordPress plugin, a bunch of stuff going on. Anyway, it's asking me if I want to log in. And so, of course, so I'll do that, and I'll do the fancy login. Once again, scan the QR code. Let's do it over here, just to show off. And hello. And now I am logged in as me on the forums. Yeah, there's my face. So, and of course, Leo and I did this on the podcast years ago, because as I said, the core technology has been working for some time, but it was necessary to make a practical system to solve all these other problems. And before I go any further, because I'm reminded by this tab, at grc.com/squirrel is the complete dump of all of the technology. An explainer for Squirrel, the operating details, all of the crypto details, and then the on-the-wire protocol bits. So using these documents, which are freely available, as is the whole system, anybody who can code can implement Squirrel pieces. And as demonstrated by the fact that lots of people other than I have implemented and are implementing Squirrel pieces, it isn't that difficult. Not that I'm, you know, such a big deal, but still. Okay, so the way traditional crypto works is it relies on something that is a so-called one-way function, something that is easy to do but cannot be undone. And we've talked about this on the podcast through the years. In this case, the easy thing to do is to multiply two large numbers. And interestingly, and counterintuitively, despite the best minds in the world working to solve this problem, factoring is not something we know how to do. So what's the crypto gods, the guys that originally invented the cryptography a long time ago, public key cryptography, they said, okay, we're going to take a large prime number, really big, 256 bits, and we're going to hide that by multiplying it by another prime number. So when you multiply two numbers, the result is twice the size. Thus, the public key, which is the product of these two primes, is big. It's twice as big as the private key. The magic of the math is that you can use the public key, which contains the private key as one of its two prime factors. You can use it to do work, even though you've multiplied it by another prime. Yet, because we have no idea how to break that public key back apart into its two pieces, we know the private key is in there somewhere. We just don't know where. We don't know what it is. And again, amazingly, despite the best efforts of the smartest mathematicians, because you'd get a Nobel Prize at this point if you could factor a big prime, they can't. So the way the cryptographic system functions is you use a random number generator to generate a test number, a big 256-bit test. Because one of the things we are able to do is test for primality. We're able to given a number, we're able to do some relatively quick tests to see, is this prime? Now, The other weird thing is that, as we know, a number will be prime only if it has no divisors less than itself other than 1. That is, 1 and itself. So obviously, even numbers, they're out because they can be divided by 2. Every third number, out. Every number ending in 0 and 5, out, because they're divisible by 5, and so on. So what's really interesting is that since the rule is a big number is only prime if none of the smaller numbers that came before are divisible by it, you'd think that you'd kind of run out. That like once you got really big, it would be really hard to have a really big number not have a divisor anywhere else, anywhere between 1 and it. Turns out we're wrong. There's no end of primes available. They're as rich out in the big number space as they are in the small number space. So we take a random number generator, take a guess, we check it for primality. If we find out that it's divisible by something, we throw it away and get another one. And we repeat that process until our random number generator gives us a private key which is not divisible by anything other than it and 1, thus it's prime. Then we do that again to get a second prime, and we multiply them to get the public key. The point is, this is a random process, and that's the way crypto has been until relatively recently. Over on this other page, I have I was doing some research for the podcast 6 years ago. I wanted to explain to everybody elliptic curves, a different way of providing public key encryption, where you could have a public key and a private key, and they have the properties that we've come to know and love and need in modern cryptography. And so this is Dan Bernstein's page on his site at cr.yp.to. He loves that domain name. It's cool. And so as I was reading about curve 25519, and it's like, yeah, okay, fine. And you can download the library and it's free, and here's how you build it and so forth. And then he comes to here, computing secret keys. Inside your program, to generate a 32-byte, so 256-bit, curve 25519 secret key, start by generating 32 secret random bytes, so 32 random bytes from a cryptographically safe source. And those go into an array called mySecret, sub 0 to sub 31. Then do, and there's these 3 little lines here, which is so cool, because he's taking the 0th byte, and those who code in probably any language, you'll recognize what this is. Basically, he's turning off the hex 08 bit of the 0th byte, and then on the other side, the 31st or the 31, which is actually the 32nd byte, numbering from 1 or 0, which is always a mess. He's turned off the high bit because he's ANDing by 127, and then he's turned on the 20 hex bit. Anyway, he says, so what this said is, you take 32 random bytes, you just tweak the first and last byte a little bit by setting some bits on and off, and you have a private key. That's a valid curve 25519 secret key. And he says down here a little bit on computing public keys, he has a function where you give it the secret and it returns the public. So there is a make public key function that makes the public key from the secret. So I'll go back over to this where I converted those to hex, so it's a little bit easier to see. But that's the way, unlike traditional factor-based prime factorization secret crypto, this is the way you create a private key with elliptic curve. And so I read that, and it's like, okay, cool, that'll be neat to talk about. My podcast audience is going to think that's neat. So I don't really know how much time passed between when I read that and the breakfast I had. But a miracle occurred, and where I like stopped chewing, and I thought, wait a minute, can this work? So the big difference here is that traditional prime factorization-based crypto chooses its private keys at random. And as I just said, test them for primality. If it looks like they're prime, we're good to go. Elliptic curve crypto can also choose the keys, the private key randomly, but it doesn't have to. You're able to tweak some bits, and that's really the gold here. What this says is that we can specify the private key we want to use. Any private key, any 256 bits, tweak the top and the bottom, and we've got a valid elliptic curve private key. And that is Squirrel in a nutshell. What we then do, and this is what I consider actually, and I can explain this, it's not that complicated. It's pretty easy actually. The user has one master secret. That is, and we call it, I use the term your Squirrel identity in a couple different ways depending upon the context. But this is your super master secret that never leaves the client, that is always encrypted and that we protect. And it's if anything ever happens to cause that to escape, then we have some remediation that I'll talk to in a second. But the key is that this key keys an HMAC, and we know that an HMAC is a keyed hash, essentially, a message authentication code where we feed into it the domain name of the site we're wanting to authenticate to. So that domain name gets hashed under the secret key, and in there, I didn't show it here, we tweak the high and low bytes a bit to create a per-site private key, which is based on the site and us. So us and the site, we get a per-site private key. We then run it through that make public key function, and this is our identity. So that was one of the key insights, was that our identity that we are known to at the site could be our public key. Because with elliptic curve signing, you use the public key to verify the signature that was made with the private key. So we take the rest of this URL, which includes, of course, because it's Squirrel, the nonce here is called the nut, and some non-predictable, never happened before gibberish, so that we're sure we're being asked to sign something unique, something we've never been asked to sign before, so that we can't be impersonated and there's no replay attack problems and so forth. So we sign this with our private key and return that signature as the authentication of the identity which we are claiming with our public key. And in a nutshell, that is Squirrel. That is the essence of Squirrel. All of the crypto that has been used to build both clients and servers is in the public domain. It's on GitHub, it's in Libsodium. Libsodium has bindings to every language imaginable. Someone's working on a pure JavaScript version, because you can, using these libraries. You don't have to use the Libsodium libraries. There are some others that have the same functions, but this has been vetted and time tested, and it's bulletproof, and it's also what I use. So basically, restating what I just said, but with a bit of a picture, we get the user's per site private key, that's after the hashing. We run it through the make public key, which claims the identity of the user. We add whatever commands the client wants to send. We also always include what it was we got from the server. Initially, that will be a URL, but then in a back and forth between the website and the Squirrel client, it's just the whatever data was returned from the previous query by the server, we send back unmodified, and that always contains a nonce which is moving forward and never repeats. We take that, run it through with the private key, the signing function, and append, attach to the end of that envelope the signature for that. That's what we send to the server. The server receives it and just reverses the process, basically. This is the identity we're claiming. It makes sure that everything is correct in the envelope, then uses all of that along with the signature that we attached to verify the signature. So essentially, that's the system. It is so that gives us per user, per site, public key assertion, and we're signing a nonce with a private key which never leaves the system. So let's step back for a second. What do we have so far? What does this mean? Potentially, a user would create that 256-bit master key once, and if everything went well, they never have to change it. They could use that identity throughout their entire life. And one of the reasons is that we're giving servers no secret to keep. It receives and records that public key with which it recognizes the visitor in the future. It can't, and this is what's different from traditional credentials. That public key can only be used to identify the user and confirm their identity by verifying the signature. It can't be an assertion of identity. By comparison, username and password. The reason we're all scampering around having to change our usernames and passwords when a site gets breached is that if those credentials get out and someone runs them through a GPU-based hashing program, you can have the hash reversed, they can figure out your password, and then impersonate you. The point is, all other traditional authentication systems are brittle from the standpoint of the site being hacked, not Squirrel. All we're giving the site is our public key. And that's why having a computer at this end makes the difference, because then we're able to computationally answer a challenge. Also, since we're dynamically synthesizing the identity from our master identity and through the hash function, the domain name, there's no accumulation of anything in the client. The client's not getting bigger and bulkier or having to remember everything that we've done. When you go back to a site you haven't been to for 5 years with the same identity, you're going to get the same public key. The site will still recognize you as who you were before. And as I mentioned, the nonce keeps us safe from a cryptographic standpoint. And there's nobody else involved. It's you and the site. There is no third-party involvement of any kind. But with that, with great power comes great responsibility. So we had to deal with the things that could go wrong. My computer crashed. I didn't have anything backed up. How do I get my Squirrel identity back? Because there is no, oh crap, I forgot my password, or I'd never tried to remember it in the first place, get out of jail, mail me my login link. Doesn't exist. Or I had a little too much to drink, and I came up with a really neat password for my own Squirrel client, and when I tried to use it this morning, it doesn't work. So maybe I typed it wrong twice last night, whatever. Now I can't log into my own Squirrel client. How do I recover from that? Or this computer's been acting funky. I think it may have malware in it. So maybe my identity is no longer something I can trust. How do I change my identity? What about changing that key that has now been used all over the internet? Or I was traveling abroad, went across customs. They snickered about my phone behind a screen, and they had it for half an hour. I don't know what happened, but I want to change my Squirrel identity. How do I do that? And here's another trick, because there are some there's some problems when you create what I call a tight identity binding. That is, a username and password that is loosely bound to you, to your identity, because you can give it to your neighbor. And if you want them to log in with your Netflix account or use your Wi-Fi, those are loose bound identities. Well, it turns out that's convenient. Mom and dad share the banking account login. Well, they want to have their own Squirrel identities, okay, but now how do they then log in to a bank where traditionally they just said, oh, here's the password, and so forth. So what Squirrel does, because it is one identity to rule them all, is it creates a much tighter identity binding, but that comes with some challenges. Some things we used to be able to do may not be as easy. And the other is I need to share access to a website, but with Squirrel I cannot share someone else's username and password. So what do we do? Oh, and the one above it, I was actually answering this last question. The one above it is, with a tight identity binding, I am known to some site as my Squirrel identity, but I want to log in there as not me. That is, I don't want to be me. In the current world, we get a throwaway Gmail email address, and we just make up a username and password, and we're anonymous again, right? The site doesn't know us. We create an account. Now we're different from our main account. So my goal here was to have a solution, to come up with an answer to every one of these questions. Because for Squirrel to succeed, it has to be free, it has to work and be secure, but it also has to have answers to these gotchas, which nobody else has really dealt with so far. Squirrel's not just going to immediately replace usernames and passwords overnight. It never will. It can conveniently operate side by side. It can be an alternative way of logging in, which Squirrel users choose, but I'm sure usernames and passwords are not going away. Well, if that's the case, as we know, security is only as strong as the weakest link, and usernames and passwords are the weakest link, and if they're still there, then yeah, I got great super killer Squirrel login that no one can ever crack, so they just crack your password. Whoops. Okay, so we have solutions to every one of these problems. So let's look at them each. The first issue is backup. Every one of us has thumb drives. We probably have more drives, more bytes of storage now, personal storage, than we can count. We're gadget people. We love them. But the fact is, no backup medium is as offline, safe, and durable as a piece of paper. If you had a zip drive cartridge with some critical data on it today, you might have a hard time reading that zip drive, or a Jazz drive, or an 8-inch floppy. Good luck. But paper? No, here it is. Look, it still works. Battery doesn't run out. You know how much storage it has. You can take extra notes on it if you want to. It's amazing. So part of Squirrel asks the user to do one thing just one time, and that is to print out 2 pieces of paper. The first is the rescue code, and we'll be talking about that a lot here in the next few slides, the rest of this presentation actually, because it is part of the system that is that's part of the get out of jail free card. It is generated by the system at the moment you create your identity. Since users cannot generate random data, which is why grc.com/passwords is amazingly popular. People go there just to get some gibberish. They like my gibberish that comes out of the GRC site. So okay, fine. Here the system generates at absolute random, a 24-digit rescue code. So think of that, that's 1.5 credit card numbers long. Not burdensome, not something you should remember or are expected to, but it is, Leo was talking before about the PBKDF2, and you saw how slowly that green bar moved across. We'll be talking about what that is in a second, but because Squirrel incorporates a future-proof and acceleration-resistant system for slowing down guessing. So this is the use of this rescue code is behind that slow process. But you just print it out and, you know, put it with your other important documents. Put it in a safety deposit box. Give it to your attorney. Roll it up and stick it down in the toe of an old shoe. Do something, but just have it once. And the other is the actual identity. The entire Squirrel identity is representable as a QR code. It's one of Squirrel's several standards that it implements. That, for example, is the way I got my Squirrel identity in my phone. I let my phone see my Squirrel identity in the app, and it said, oh, so you're able to easily transport your identity among your devices. Well, and that ends up being a handy backup solution, because as your one Squirrel identity is on your work computer, your home computer, a smartphone or two, and maybe a tablet, well, you've got backups now. So if it dies somewhere, you have the same identity elsewhere. It also, Squirrel, because I'm sort of old school, and I'm thinking, well, we think the QR codes are going to last forever, but, you know, one thing we know will at least outlast them is text. And so there's also a textual representation if, for example, you wanted to put your identity into a device that did not have a camera and where it wasn't convenient to transport it as a file, because you could also transport it as a file. In any event, 2 pieces of paper, the identity, both as a QR code and text, and separately the rescue code. You need them both. So so another cool thing is you store them separately so that if either one of them were discovered, the rescue code by itself does nobody any good. Your identity by itself does no one any good because it is encrypted. Every time the identity in Squirrel is stored encrypted, it is briefly decrypted for use, and then that decrypted version is wiped from RAM. So all the exports of the identity are encrypted. It doesn't ever exist in unencrypted form. I talked about the PBKDF. The problem with Bitcoin is that it's proof of work, that is the thing you had to do in order to earn a Bitcoin, was come up with some data or add to some data such that the SHA-256 hash of it had some number of least significant zeros. And it's harder and harder to do as you require more and more least significant zeros over time. That's how Bitcoin's proof of work is able to scale. The problem is it was just SHA-256. That you can put in silicon, and boy, did they. So first it was GPU acceleration, then it was ASICs. So, you know, now there are towns where the lights dim in the evening when the Bitcoin miners start up because they're just pumping out so many hashes. So what that meant was that SHA-256 was not acceleration resistant. Script, which is a very cool PBKDF developed by Colin Percival, he was creating a cloud storage system called Tarsnap, which I've talked about on the podcast in the past. Script is his solution for something that cannot be FPGA'd or GPU'd or even ASIC'd because those things have computation. They don't have memory. Memory is too expensive. So when you think about it, I mean, they have a little bit of memory to compute on, but they don't have a lot. So we choose, the way Script functions, we choose a 16 megabyte array. We put the password in, the password keys an HMAC SHA-256 pseudo-random number generator, which fills this with pseudo-random data modulo 16 meg, meaning that all the values that are in the cells are 0 to 1 minus 16 million. In other words, if you considered this a value was a pointer, every cell is going to point to some other cell in the array. So the first phase fills this with the 16 megs with pseudo-random data. Then a pointer walk starts at one location, reads the value there, puts that value into a hash, then jumps to the cell that value points to. Does the same thing, takes that value, puts it into the hash, uses that as a pointer, jumps to the cell that points to, and so on. So this thing zooms around within this array for quite a while, pouring data in a sequence into the hash. So the cool thing about this is every time you put the same thing in, you get the same array, you get the same hash result out. But you really do need 16 megs of RAM. Theoretically, you could compute the nth cell and then go there and then create, compute. And it turns out it is far more time consuming, and time is what we're trying to consume here, far more time consuming not to have 16 megs and try to do it algorithmically than to just say, okay, fine, 16 megs, follow the pointers around, and we get our result. What this means is that it is powerfully memory hard, as the term goes. Unlike SHA-256, in effect, Scrypt is being used by some of the cryptocurrencies specifically because it levels the playing field. It makes it much easier for people who aren't going to dim their city's house lights in the evening to still play in the cryptocurrency game. So that's one piece of technology. I want to show you two more. The first I call nscript, as in we're going to enscript something to do it to it. We use the script function because I could have used even more memory and made it even slower, but the range of devices we want Squirrel to run on varies from, maybe a little dongle token thing that's lower powered, or an older Android smartphone, up to a state-of-the-art, triple scoop, whatever, multi-core behemoth. So because we need to put the identity in and run script on it, the size of the array had to work in the lowest common denominator device. But that meant it was still too fast for the super fast machine. So I came up with this idea of iterating over script. That is, you do script, you take the output of that one with the password into the next one, you XOR their results, and you do it again, and you do it again. The point is, you do it until some length of time has elapsed, and the user can set that. When you saw that green bar move across, that's because I'd set it to 5 seconds, which is the default. And so the idea is, when we are encrypting the user's password, we start a timer, and we iterate, counting how many times through script until we get past 5 seconds. We store that iteration count along with the parameters that we use, because those can vary over time. And then when we are decrypting it, we don't use time. We use the iteration count that we captured the first time that we encrypted it. And when you move to a slower device, it may take like 15 seconds the first time, but then it adapts and re-encrypts so that it's only 5 seconds under your new platform. So it ended up solving all these problems. The one other thing that I did, there's one place where we absolutely positively don't want any future to be able to go to in a reverse direction through a hash. We no longer consider SHA-1 to be secure. We had MD4 and MD5, those are gone. Once upon a time, they were fine, but they're not fine anymore because we got faster. So it's foreseeable that eventually SHA-256, oh, well, shoot, sorry, we chose that. So I didn't want to rely, I wanted to have a hash that I could absolutely know could not be reversed. And the scary thing is that hash functions themselves are iterative. They have some number of iterations. And I don't remember now, SHA-256 might be like 20 iterations. And if you do 13, it's not operating quite that well. So it's like, ugh. So that gives you a 7 iteration margin to be like absolutely sure? No. So anyway, so I do 16, just because belt and suspenders, 16 iterations of SHA-256, XORing all of the intermediate products to create something that I call N-hash, and there's no way that is ever going to get reversed. Okay, so I changed my password last night, and this morning I forgot what I changed it to. You know, the one password you need is the one you use to unlock your identity for your own client, if it's in your phone or if it's on your laptop. So, well, first of all, if you have your paper backups, you're always safe. So given that you have your paper backups, not a problem. You could always go from there. But as I said, there's no one to receive the, oops, I forgot my password link. It's a little daunting at first, but it kind of dissolves easily if you spend a little time looking at it. This is the key flow for Squirrel. We start with a completely random 256-bit value, which we call the identity unlock key. We'll be coming back to that at some point, because we run that through make public key to the encrypted identity lock key. Again, that'll be useful in a second. Here's where N-hash happens to get, this is the working key that we use. That's the one that you saw us earlier running through the hash function. So it's not actually derived randomly. This guy is derived randomly, and it's derived from that. The reason is that this is the super secret, which is encrypted under this 24-digit rescue code. That is run through NScript, so that's the PBKDF, the really slow 24 digits goes in, creates a key. We use GCM encryption to take that, encrypt it, and store it in the user's identity. So the user, this is the user's stored identity. So it has an encrypted version, encrypted with the rescue code of this grandmaster, and the grandmaster creates the working identity, which is encrypted with a password. So, and that is also stored in the user's identity. So during the day, when you're just normally using Squirrel, you're putting your password in. It is decrypting this from the stored identity to recreate the identity master key, which is what is used. If you were to forget your password, you don't know what this is now. Well, this is what you were normally using during the day. Your identity is encrypted here, but you need the password in order to key the decryption function. You no longer know what it is. That's okay. The rescue code is your get out of jail free card, because the rescue code, which you printed out, right, and stored away somewhere just for the rainy day, you don't need it. You can potentially go through your entire life using Squirrel, never, dust those pieces of paper off, and probably. But if you forget your password or other things befall you, they save you. So you get your 24-digit rescue code out. It is able to decrypt the super key above the one that you use, pull that out of your identity. That brings you back to here. We run it through N-hash. All is forgiven. We're back to your original master key. You give it now whatever password you want to, and it then re-encrypts it to store it for daily use. So it works. What other things could happen? My computer was infected with malware. I'm worried that my identity might not be safe. How do I change it? or related, like something has happened, in this case, in this example, traveling abroad, where you feel like you need to do something here. You need to, some way to change your identity. The other piece of really sort of cool technology, and I don't use the word invent casually. I think most people engineer solutions. This one was the result of a very large quantity of caffeine at Starbucks, because my intuition said there was a solution to this. There had to be a way to do this, and I was just going to sit there and caffeinate until it came to me. And I worked it out on paper, and I'm not quite sure how it works. Every time I check it, it's right, but it's like it's kind of slippery. It's just like, I mean, I invented it, but I don't know how. But I know why. The concept was, as you are roaming around the internet, using Squirrel for the first time, you go to a site you've never been to, and you're like, oh, look, they now support Squirrel. Cool. I want to switch over to using Squirrel, because why not? So you go through a process we call associating your identity, that is your Squirrel identity, with your existing identity. For example, you might log in for one last time with your username and password, and then there would be like a button, like start using Squirrel. So you click that, it gives you the QR code, or probably just click here to start using Squirrel. So you click that, your Squirrel client pops up at prove to me you're really you. So you do your Squirrel password that now you've been forgiven for having forgotten before. Now the site knows you. What I wanted was a system such that if a bad guy got your phone, or the authorities, or the NSA, or whatever, they would not be able to remove your identity. They would not be able to change your identity. It would be, that is, once you have associated your Squirrel identity with a site, it's locked. It cannot be changed unless it's you. So as you were going around the internet, you were creating these new associations. So the way I phrase it is, I wanted technology that would allow the Squirrel client to create a new logical assertion which it could not prove. That is, it could make assertions, but it could not prove them. Because if it could prove them and a bad guy got it, then the bad guy could use it too. There had to be like something else, something that you weren't walking around with you and your Squirrel client on your smartphone or your laptop during the day, so that if anything happened, that there would be some missing information. The missing information is the rescue code, which is in that shoe somewhere. So what this does, and I really can't explain it, so I won't. I mean, yeah, if I had to, but it's a series of equations, and in fact, on the next page, there is a link to what we call the ID lock, and it is all explained in the documents. But essentially, when you create your identity, two other pieces of information are saved by the server. Your public key, your Squirrel identity, your public key, and these two things we call the server unlock key and the verify unlock key. So there's essentially three 256 pieces of information. That's all that the server needs to store, to do everything. And then if you should ever want to change your identity, you provide the rescue code, which is made available. The server returns the unlock key. You do a Diffie-Hellman key agreement to produce the unlock request signing key, and then the server is able to verify it. Again, I'm not going to bog us down by going into it. The equations work somehow, and the system works beautifully. What this means is that there is the rescue code is not only the get out of jail free card for things that happen, but it sort of provides the notion of an authentication hierarchy. It's got more power than what you're normally doing with your smartphone and your laptop, which means if you lose control of them, the bad guy doesn't get that higher power. That's the rescue code stored safely offline somewhere, which can come in handy. So the way we handle changing identity is cool. Another way of looking at that, the Squirrel Secure Storage System, is there's 3 blocks. One is encrypted under the user's password so that the password is able to decrypt it in order to use it. The rescue code, there's some rescue code encrypted data, naturally encrypted with the rescue code. And then there are some number or 0 previous identity unlock keys. So what happens is you can have, and we have it set to 4. There's no limit. For a while, I just had 1, but I lost a political battle in the news groups because my theory was, well, you know, you should really never need to do this, so you don't need a lot of them. And they said, well, yeah, but let's have some more. I said, okay. Well, and I shortened that political battle that was about several months down to about 3 sentences. What this does is, if you want to change your Squirrel identity for whatever reason, you no longer trust it, malware got into your system, something happened, the current encrypted identity unlock key, and you need your rescue code for this, it becomes the first previous identity unlock key. All of the, if there are any, older previous keys essentially get pushed down the stack. So this is the most recent 4, and the 4th one, which you probably didn't need anyway, gets thrown off the end. And a new random identity unlock key is generated to populate the top half of the identity. So what this means, in short, is the Squirrel identity, which you're using to log into websites all over the world, it contains your current identity and up to 4 previous identities. And this ends up being very cool because this is the encrypted previous identity unlock key, which is encrypted with the identity master key, which is here, which means you can get to it with your password. So what I'm saying is that the rescue code is required to unlock your current identity, but any of the previous identities contain their own unlocking information. That's useful because what happens is, I don't remember if I have a slide for this. Oh, nope. What happens is when you have rekeyed your identity, which is something you can just do sitting at your computer. You say, there's a button on the client. I'll show you. Because here's Squirrel. And there's rekey identity. So you click that. And I try to discourage it because I want people to understand Squirrel is different than other systems. You know, you don't have to have a different identity for every site, one identity to rule them all. You almost never really need to do this. So I spent a little time, with like, are you sure? Are you really sure? And so forth. But anyway, the point is that you can rekey your identity whenever you want to for whatever reason. When you do, your Squirrel identity contains the new key and up to the 4 newest previous keys. And it presents them to the website in pairs. That is, the current key and the most probable previous identity, if any. The website, if you have just rekeyed, won't know you by your new identity. No one does yet because you just changed it. But it remembers you by your previous identity. So the first phase of authenticating is a series of queries that the client makes offering pairs of keys. And the website says, oh, I recognize you by your, so in pairs, recognize you by your secondary identity, not your primary. In that case, the client knows that it has found a key that the site recognizes it by, and because of the other information that's in that packet that was sent, the server, the website, has all the information it needs to automatically update. That is, you have, because these keys both cosign all of the information that's going to the server verified that you in fact are the owner of the private key that matches the retired identity, and you're now presenting a new public key for your new identity that's been signed properly too. So essentially, that gives the site permission to completely forget the identity it knew you as and just ratchet to the new one. So, sounds complicated, but it's like automatic. It's very much as automatic as, like, you know, logging in with your phone, where it's just like, whoa, that's secure? How can that be? So this is all cryptographically signed so that when the user's experience is rekeying their identity and just going to different sites which they log in at. And the act of authenticating to a site updates it to the most recent identity. And so that was the case I was trying to make for only needing one, except that people said, well, what if like something happened again and you had to rekey a second time, and there was a site that you hadn't visited while you had the first rekeying? I was like, okay, fine. I mean, they're small, and you know, everything here is small and tight. You know, the identity was that little bit of text that you were seeing. That was the entire. I think that one had multiple keys in it too. The entire identity. So that gives us a solution for malware got into my machine. I'm not sure I trust it anymore. I want to change my identity. The bad guys got my laptop. Border Patrol got it. Who knows what? Well, for whatever reason, I like Squirrel. I want to keep using it, but I'm worried my original identity may no longer be safe. Right on your machine, you can rekey, and then as you visit various sites, they update from the old to the new. And as you do that, of course, if the bad guys do have your old identity, it no longer works at those sites that you have visited because they've forgotten you. The moment you touch them with your new identity, that erases the old identity. So it essentially allows you to take your identity back if it gets out of your control. The question, one of the other problems was, what if I want to go to a site as someone else? I have a Squirrel identity, site knows me as that identity, but now, for whatever reason, I want to be sneaky. I want to do something, you know, else. Well, it's something we do now with usernames and passwords. We just make up another account, and the site doesn't know us, and we go from there. It turns out there was a simple hack, which is to the domain name which we're hashing, I just add a null because it just separates the domain name string from what we call the alternate ID. Essentially, we just add our own little bit of something to the thing that we're hashing, then that's going to create a completely different identity. And just to give you a sense for the way it looks, I mean, it's just log out, and so sign in, and here under options, there is use alternate identity for, and it knows the site I'm at for the Squirrel demo site. And this can be anything. It's just, okay, that's a Z. That's my alternate identity. Or, you know, so the point is they're named alternate identities just for convenience, because I just had to have a string that you added to the hash. So you might as well let it be whatever you want to. You could just use 0 as your alternate identity. And that's going to create a completely separate. That is, the site will have no idea it's actually you. That is, that if there was no Z there, you'd be you. But if there's a Z there, you look like a completely different 256-bit public key. So there's no trackability from your old identity or your base identity to this. And this allows you to create, as many identity forks as you might want to, and this system all functions through the rekeying process. So that's all transparent there too. And so, you might, use a meaningful name for you. Maybe you know why you're wanting to have a different identity, so you use that as the string. But anyway, it's a simple solution for solving one of the other problems that we created when we have a tight identity binding. The other one was, the other solution or the other problem was mom and dad want to share the household bank account. They each have their own Squirrel identities, but now what do? Because neither one of them, it doesn't make sense. I mean, the idea is your identity is yours, you don't need to share it. But there's a case for needing managed shared access. And once upon a time, I thought that I was going to have time in this for a demo, but there isn't time. But I can describe it very easily. It's a simple invitation-based system. That is, with managed shared access, you have a flag of users are either managers or not. Mom and dad would be managers. Betsy and Johnny are not managers, but they're all able to use their Squirrel identities to log into Netflix. A manager is able to generate an invitation, which is another one of my favorite 24-digit strings. They provide that invitation out of band. Just email, write it down. I mean, it's not that long, 24 characters. And, so mom gives it to Jimmy and says, here's your invitation. Jimmy logs into Netflix, and with his Squirrel identity, and Netflix says, don't know you. And do you have an invitation, or would you like to create an account? Because if you're not known, you want to create an account, but maybe there is one you want to join. So Jimmy puts in his 24-character invitation, which is associated with the account that mom or dad have, and now you have managed shared access. The managers are able to bring up a list of everybody who is authenticated, everyone who's accepted invitations. You're able to remove them selectively. You can name them for handy identification and so forth. I built the whole system, I better not get into it because it's fun to show it. But it works, and it solves the problem of how can multiple people share the same account. It does require server-side support. That is, so it's not something that can be done on the client end, or I would have done it. It needs the server to offer managed shared access. And I recognize that, it's enough of a hope that the server is going to recognize Squirrel at all, let alone managed shared access. Ultimately, though, I wanted to design a system, I wanted to have it in place so that if the need arose, they'd be like, yeah, we got that. We already solved that problem. Here's how you do that. Probably in the interim, mom and dad would create a third, and I hate this, but yes, a third Squirrel identity. They would have an identity they share. So dad has his own, mom has her own, and they have a shared identity, call it, ours. And that's the identity that the various websites that they explicitly share would know them by. So it's not as elegant as only using your single identity. We have a solution that allows you to do that. But if for some reason, you need to share a site, you certainly could create an explicitly shared identity. And as managed shared access came along in the future, you could then phase out of using that as you were able to share in the proper way. One of the other problems we talked about, yeah, Squirrel's great, but I still have passwords everywhere. And we know that weakest link is the way security operates. So this is another one of those things where I put it in there so that it's there from the beginning, because it's always harder to add things later. There's 2 checkboxes in the settings and options for all Squirrel clients: request only Squirrel login and request no account recovery. They're just status bits that that Squirrel sends to the servers it's authenticating to every time it authenticates. They are sticky in the settings and options. So they default to off, because I don't want to do that until, I don't want users to do that until they're comfortable with Squirrel. They've printed their rescue code and their identity, and they're sequestered, wherever they keep their safe things. They've used Squirrel for a while. They understand it. They're comfortable with it. Now they're like, that's all they want to use. So request only Squirrel login is a beacon that goes to the site saying, I want you to disable my username and password login and everything else. Turn it off. I know how Squirrel works. I love it. And that, and because having multiple ways to authenticate is way worse than having one secure way kill off the other ones. And then the other is request no account recovery, meaning no amount, I'm telling you, I've turned this on, you've seen it, no amount of begging and pleading from me, because it might not be me, right? No amount will cause you to send me anything to let me back in, period. That is, the system is robust, it's reliable, it works, and the problem is the way people are getting into people's accounts now is spoofing. We were talking about it just this week with the SMS and Twitter spoofing. So what you want to do is you want to say, I only want to use Squirrel, and I don't want anybody who calls up and pretends to be me to be honored. Just say, well, gee, Steve, we're really sorry, but did you see this little thing you turned on here? Can't help you. No, really, it's me. Sorry, can't help you. So we had to have a solution for that. Again, and I called it request because, again, I can't enforce that. That's not something that the client can make happen. It's just it just says to the server, I would like you, it's a request. I'm requesting that you disable other forms of login and that you don't believe anybody who calls up pretending to be me and asking for, to be mailed a password link. This was the big question we had, and over the course of these years, I fought a lot of battles because there were people who were saying, well, Steve, this is really great, and we have a chance to do something new and fantastic. How about form fill? And it's like, that's not authentication. And, oh yeah, but it would be really nice not to have to fill in forms. And it's like, well, yes, but there are other solutions for that already, and they're fine. So the question was, should we go beyond authentication? And I decided there were 2 things that I wanted to do that made sense because they were unique. The first was to make it possible to give the website a secret which it would not store. That is, it's storing our identity as our public key, but it's a public key, it's not a secret. So, and actually I probably got the idea from LastPass because that's what they do also. We know that they store the encrypted blob of all of our usernames and passwords in their cloud, but they have no key for it. We have to enter our password. It runs through the PBKDF2 to create a key that then allows them allows that blob to be decrypted. They don't have the key, they don't want the key. Well, that's a really useful model moving forward. The idea that sites could be storing information for us. I mean, even sensitive stuff at some point, health records, it's inevitable, is going to happen. Yet, they want to offer the ability to do that without the responsibility of what if they get hacked. They don't want to have the keys. So this is a very simple add-on to what we already had. We'd take the private key, run it through the really cannot be reversed nhash function, use that to add to HMAC with what I call the website's secret index. So the site provides an index, again, digit 0. Doesn't matter what it is, because we're going to HMAC it through something that is unique to the user and the site, and that produces a 256-bit index secret, which could then be used while you're logged in to decrypt the data that it is storing for you so that you can do things. But once you log out, I mean, again, this is like a service to the website, and it's built into Squirrel. So it's there if they want to take advantage of it from day one. That allows them to store stuff that they cannot access. The other thing that I wanted, the thing that was different enough from existing systems, was we call it the ask feature. That is, we have a unique opportunity here where the client is talking to the web server outside of the browser. The browser is a cesspit, as we know. I mean, it's amazing that it's like still standing. It's just because everything is attacking it. It's like it's a disaster. And users are easy to fool. So it's easy to spoof something that the browser is presenting that is much more difficult outside the browser. So I decided to, again, it's not authentication, but there's nothing else like it anywhere. And I thought, well, let's put it in there. Doesn't have to be used. It was simple to implement. We call it ask. This allows the website to get an explicit confirmation from the Squirrel user where the website provides the content and can label up to 2 buttons. And so in this example, please confirm that you really do want to have us transfer all of your life savings, all of your investments, and all of your accumulated wealth to a numbered account in the Cayman Islands. And then it's, wait, what? No, abort. Or, yes, please make me poor. So this comes through the Squirrel channel and and it's authenticated. The user's answer is signed in the query that is generated when they make their selection. So it's very cryptographically robust and unspoofable, and it made the cut of nothing but authentication except, okay, 2 little things that I did want to have. We were talking before I started about the inherent problem of networking authentication. When you go to your doctor and shake his hand, you see each other. You are each other. You get that real world authentication. The moment this thing goes over the network, hackers start having a field day. This is subject to abuse, the man-in-the-middle attack. So this is one of the things, while I was working on Squirrel, that I wanted to give a lot of attention to, see what we would be able to do. A classic example would be that a user logs into Joe's Garage. And look, Joe's Garage supports Squirrel. But the Joe's Garage server went over to Amazon and started to log in and got the Squirrel code for Amazon, which it's presenting on Joe's Garage page. So when you authenticate to that QR code or click sign in with Squirrel, you're actually authenticating your Amazon identity, not your Joe's Garage identity. That's a problem. So it turns out we have solutions for that. The Squirrel is IP aware. So it knows the IP that asked for the original QR code, which in the case of Joe's Garage would not be your IP. You have a different IP. So when your client authenticates that QR code, that's coming from a different IP than originally asked for the QR code. In a normal environment, this is all happening in your browser. Your browser at your IP asks for the QR code for the login page. Then your Squirrel client in your desktop does the authentication transactions with the same IP. And so we call it same IP in Squirrel. There is a problem, which is you could be in a large organization behind the same NAT router. Now you've got different people who do have the same public IP, because that's, of course, what the Squirrel systems, the Squirrel server sees the IPs coming in for the request and the authentication. So we needed something more. I'm sure I've talked about it on the podcast, because when I came up with it, I was so excited. We call it CPS, Client Provided Session. The idea is that the man in the middle is a problem, because the man in the middle, by the nature of the term, is intercepting, is placed themselves in the middle, intercepting everything that happens between the web browser and the website. So this, if they're able, I mean, and there still is a high bar to lift. You've got to somehow decrypt the traffic. You have to have a TLS certificate. You have to be able to spoof DNS and blah, blah, blah. I mean, not an easy attack to mount, especially in this day where everything is HTTPS now, but theoretically possible. What I realized was the Squirrel client is a separate entity. It's authenticating with the website server. So what if we allowed there to be communication, almost a back channel, between the user's web browser and the local Squirrel client? And it works. The client sets up a little web server on port 25519, of course, because that's, curve 25519. It sets up a little list. It listens to connections, for browser connections on the local host IP, that is on your own little internal network here that we all have at port 25519. The browser asks the client for the next page. It jumps to, essentially tries to bring up the page there. Then the Squirrel client performs the authentication, and the Squirrel client says there's a flag saying, we've got client provided session. The Squirrel's all excited over here because the browser has just jumped to it saying, tell me where to go. So the client adds a flag to its dialog saying, we're using CPS. Do not authenticate the browser session. When I log in, do not authenticate the browser session. Give me a URL for the browser to jump to. And so what this does is it beautifully cuts out the man in the middle. There's nothing, this guy never gets an authenticated session. Instead, through this Squirrel secure channel, the website gives a URL, and so what happens is the user's browser has jumped to us. We return an HTTP 301 redirect, which bounces the user's browser to the authenticated page on the website, cutting out the man in the middle. So it is just, it was something that couldn't be done if we didn't have the kind of architecture that we do, but now that we have that, it provides us very robust protection. But only for what we call same device authentication. That is, in order for that to work, the browser in the laptop had to be able to jump to the local host server of the Squirrel client in the laptop in order for that to happen. Sexy as this is, I mean, and it is cool to be able to have your phone be your authenticator and look at it and go, yeah, and then you're logged in. There is no, we have racked our brains. I have, and the group in our user groups have, trying to come up with any way of strengthening the authentication in what we call the cross-device mode. I don't think it's possible. You can certainly use the Squirrel client that's here to log in to sites on Safari or Chrome or whatever, the browser on your own on your phone. There you're in, again, same device authentication. But cross-device, there just isn't a way. We would need some sort of a channel from the browser to the phone and back. And maybe someday NFC or Bluetooth or something. But the fact is, cool as this is to use a smartphone, and it can certainly come in handy, the way we're all logging in today is same device. We're just, we're logging in with the device that we're using. So, and there, Squirrel provides really, really robust protection. The server side of this is simple. That's one of the things that I was really happy about in terms of getting this adopted. We only need clients for a few platforms. There are many more server environments than there are clients. Android, iOS, Windows, Mac, Linux. Okay, I'm done. Chrome OS, I guess. But there is a Chromium plugin, so we have a client for any Chromium-based browser, and that's available and working. But many, many more servers. So the cool thing about Squirrel is most of the work is in the client. The server has only a few things it needs to do. Store those three 256-bit keys. It needs to generate an unpredictable one-time nonce, the so-called nut. And I have a favorite way of doing it. Bruce Schneier designed the blowfish cipher a long time ago. It's no longer considered secure because it's only 64 bits. And that's just not enough bits in a block cipher. But it's perfect for our purposes because I can take a 64-bit monotonically increasing counter, meaning one that will never give us a lower number than it ever gave. It only goes upward, and we store each result and so forth. We use that as the data to encrypt with the blowfish cipher a secret key, which is for the website. And what comes out is a different 64 bits that will never repeat. Since the input 64 bits never repeats, it's a counter going upwards, this will be completely unpredictable and never happen a second time. We base 64 URL encode it, that is, turn it into ASCII, and that is the Squirrel nut. So that's simple to do. And so the server has to generate nuts. It has to verify that the client returned what the server sent. So that's one of the things we do is that, as I mentioned that earlier, like the URL that we were originally authenticating to, and also in the dialogue between the Squirrel client and the server, this client always sends exactly what it got from the server back. So that's how we handle the fact that this is a one-sided authentication we were talking about before I started, is that the server then verifies that it got back from the client what it sent, which means that nowhere, the client wasn't confused and no interference in the link occurred. And of course, the client signs everything. So it says, I saw what I'm sending back. The server says, yeah, what you sent back is what I sent you, so that's cool. And the signature is correct. So, and I do that by just setting some max. I do a message authentication code on the data that I'm sending, and when it comes back, I remac it and verify that they match. So that's simple. And then verify every signature provided by the client. And that's one function call to the cryptographic library. So the server side is really simple. So far, I've been talking about the website and like handling Squirrel as one thing. When I was wanting to implement the Squirrel Forums, we had that neat guy, Rasmus Vind, who knew the Zenforo forum software, but he didn't know anything about Squirrel. And he was volunteering. I wanted to lighten his load as much as possible. I didn't want to have to teach him Squirrel because he knew Zenforo. So that was the genesis of the so-called SSP, the Squirrel Service Provider API, which is a well-defined standard to separate the function of a generic standard website server and Squirrel, so that the browser can talk through the internet to the SSP API, the Squirrel, the user's client, either in their smartphone or on the same device, maybe even in a browser plugin, is able to talk to the API. What's the key is that the person who writes this has to know Squirrel, and I did. And it's actually, there's now a C implementation of it and a Java implementation, so it's now in several other implementations. But what we wanted to do was we wanted to not require the website to need to know anything. So essentially what the API provides is a very simple, this is the entire API, very simple HTTPS query and reply protocol, just some simple endpoints that the server uses to talk to the API, meaning that if you have an instance of the SSP API, bringing Squirrel up on a new server platform is probably an afternoon. I mean, it is really simple. And that's the implementation for the demo site and the Squirrel Forums on GRC. So it works and it's been proven and it's available in C. I keep talking about how this is a two-party solution, but there are instances where you might want a third party. You might want some sort of a referral identity like identity.us.gov. And while Squirrel doesn't require, obviously, a third party, it's third party comfortable. The user could, so when a user goes to the website, say irs.gov, there's a login with Squirrel. Well, the irs.gov site got their Squirrel URL from the behind the scenes from the identity.us.gov server. So when they click sign in with Squirrel, they're authenticating against the identity.us.gov domain with their identity that they'd previously established with the US government, so you can have a separate authentication server which multiple websites all refer to, like all the different .gov sites, so you have a single US citizen Squirrel identity that you are known by multiple sites for. You normally couldn't do that because, of course, Squirrel is all about a separate identity per domain name. This allows you to deliberately, should you choose to, concentrate them all to a single domain name. And a domain name, yes. What if a domain name changes? All of the people that are known to the site are at, a.com, and the company decides maybe big B.com, big fish company, B.com buys A.com and wants to move everybody over. Okay, so of course at B.com, anybody who tries to use Squirrel there is unknown because their identity will be different at B.com than A.com. We can handle that. You initially log in at B.com and you're unknown there. But in the act of trying, they got your Squirrel identity, your public key for B.com. So they know who you are as you at B.com. They just don't know who you are as your identity at A.com. So they say, the page comes up and says, we don't know who you are. If you were a customer, a previous customer of A.com, try again. And there's it now. And this is now it's, log in with Squirrel. And that's at the A.com site, which allows the new domain provider to see both identities. It has your old identity at A.com. It already got your identity at B.com. So it's able to move you over, change those three keys in order to update to who you are. And we solve the problem of there being some need to migrate people from one domain to the other. So we have a solution for that. So this is the end. We support a single master identity for everything globally. There's no trackability. You may never need to change your identity again for your entire life. We have a provision for doing so if for whatever reason you should need so. It's easy, it's too easy for the user. I'm trying to say, no, really don't. Think about this. Do not, know why you want to do this. But it's completely transparent. We can handle the notion of ad hoc forked identities, and we can handle multi-user managed login. I call it identity lifecycle management. That is, it's not just here's your identity, but it's what if. Every possible what if has been resolved. It is strongly anti-spoofing and anti-hacking, like from the ground up. That's why this thing was created from the beginning. Super strong in same device mode. It is, since Squirrel gives websites no secrets to keep, they only get your public key identity. Doesn't matter. I mean, they could actually publish that database. There's nothing that they need to keep secret in the stuff that they have, unlike usernames and passwords, where it's a disaster and we're all having to run around and change our passwords when a site gets breached. Two-party solution, no central third party to trust. We are just a 256-bit number. We are pseudonymous. There's no way to do tracking through Squirrel. Of course, you still have all the cookies and super cookies and all that other browser side, but that's not about authentication or identity. You guys now probably all understand it. I mean, there's not that much to it. It is simple. It's straightforward. Nothing proprietary. All the source is up on GitHub. Multiple projects are underway right now, and a lot of it is working. Because it's so simple, it's provably secure. It is one crypto expert has gone through it and found nothing that we needed to change. And that means it's easy to audit. It's not OpenSSL, catastrophe with, endless amounts of source code. I like the fact that most of the complexity is in the client, because we only need a few of those. The server side only has to do those three things. So it's easy to bring Squirrel up on a new server, and the API makes it even easier. And it plays well with others. It doesn't have to take over the world. It doesn't have to push anybody else away. It can just easily coexist side by side with existing authentication solutions. So how does it get adopted? That is the remaining question. I have no idea. I'm not a person who prays a lot. Otherwise, if I thought that was going to work for me, I'd be on my knees right now. There are instances where Squirrel's incredibly low friction is valuable. I've always used the example of blogging because it's one we've all hit, where we read someone's blog post and we're revved up by it somehow. It's like, oh, okay, I've got something to add to this dialogue. And so you hit reply, and you are immediately, the first thing that happens is create an account here. And it's like, okay, it's not that important. I've got better things to do. I'm not giving one more site my email address. No way. Squirrel avoids that. If this site supported Squirrel, you click Login with Squirrel, and you're done. The site now has your unique Squirrel identity. You can be known to it. If you come back 4 years later, you are still known to it. So think about that. The blogging sites want interaction. Low friction matters to them. So you can imagine that those sorts of sites, especially since now Squirrel is a plugin for WordPress, which is most of the blogging sites on the planet, so it's easy to add it. And in fact, it is in lots of sites now. So there's that. And once users begin to understand this and just realize, you mean I just click Login with Squirrel? That's all I ever have to do, ever? And it's like, uh-huh. Well, then you can imagine people starting to ask for it elsewhere. So well, asking, why don't you support Squirrel? I'd like you to support Squirrel, and so forth. So, there isn't any way for this to get pushed. I believe I've solved all of the problems that are involved in getting it going. It's easy to add it to existing websites. It is a solution for the username and password problem. So, also, sites are concerned about being hacked and breached. This now is it's an issue for them. It's a reputation damage. It's expensive. So the idea that using Squirrel means that's a non-issue, that should be meaningful too. So we'll see what happens now that it exists, and it does. Yay!
Smarter now? Yeah. I feel dumber. So this is a good chance for us to do some Q&A. There is a great studio audience here who came all the way out in the middle of a bomb cyclone. And by the way, it's worse outside to watch the presentation. Yeah, I think the roof's okay. If you start hearing the rain, you'll know that it's really pouring out there. And also, and I don't know if you can do this in this show or if we should do a separate show, I think one thing I would like and a lot of people would like is, what does the end user experience look like to set it up and use it? Just as simple and as quick a demo as you could do. And maybe I'll be the guinea pig and you just show me how I could set up an account to use Squirrel, say, on your forum. Would that be a hard thing to do?
No.
It should be easy, right? Otherwise, we just wasted 2 hours.
Well, and in fact, it is certainly more involved to do that than to make up a username and password. And so you know, there is that. There's the fact that it's more involved than the traditional solution.
But you only do it once.
Exactly.
Yeah.
Once, maybe in your life.
Right.
And exactly. And then from then on, you just whenever you go to a new site, it's a slam dunk.
So should I download a Squirrel client on my Android phone? Is that the best thing to do? And then you could.
I've never used the Squirrel client on the Android.
Do I need TestFlight to use it on iOS, or is there an iOS?
You do need TestFlight.
Yeah.
It's not in the store yet.
Okay.
It's probably not the best thing to try to do here. And we do have user-created videos of all of that.
So you can watch that.
That is on the Squirrel Forum. My idea was I wanted to do the technical presentation, and then leave the user the YouTube videos of, hey, here I created my Squirrel identity, and there's a bunch of that now.
If people are already doing that, we don't need to.
Yeah.
Who has a question that they'd like to ask Steve? Your hand shot up quickly, sir. What's your name? Matt, where are you from?
He wants a pop
From
socket.
San Jose.
Nice. Go ahead.
So, Steve, what steps do I have as a user as Squirrel and as an evangelizer to others for Squirrel to validate the client? Maybe only for that first generating time, but to make sure that I'm not getting Bargain Bob's Squirrel client, or a supply chain attack, heaven forbid, hits your server, and suddenly, like the Bitcoin wallets that were generating keys that were then sent off to Moldova or somewhere.
Yes, that's a great question, and I didn't touch on it. It is, and I do highlight this over in the Squirrel Forum. So there is, I didn't really highlight this, but squirrel.grc.com are the forums, and there is a section, a Getting Started with Squirrel, and I talk there about the absolute imperative not to give your Squirrel identity to a malicious client. I mean, it's very much like if there were a malicious login manager, right? You were trusting a login manager that was not protecting your username and passwords, but was, sending them off to some other country. So there is a danger anytime we have anything malicious on our computer, but it is absolutely the case that that you want to use a trusted client. I know who wrote iOS client. Jeff Arthur, Daniel Person wrote the Android client. I wrote the Windows client. Daniel's is open source. I have opened mine to anybody who has had any use for it. But for example, I don't want someone to create an identical looking Squirrel client to mine, which is malicious. So, I mean, I recognize, it is a problem. You absolutely don't want to get stuck with a malicious client.
Is your client on your site?
Yes.
You should just do an MD5 hash that you say, this is the client. If the hash matches, then you have my client.
Except that somebody that were to put up a malicious client.
Well, but you control parts of your site, right?
Yeah, I will.
Okay, put it on the part that you control, not the forum, but you put it somewhere where it's safe.
Well, it's also digitally signed. So I have
it is signed.
EV, Authenticode,
okay. Your site is, but I'm
scoop.
saying you need a signature on the software.
Yes, the software is signed.
So
yes.
that answers your question.
Yeah.
Right?
So yes, don't use unsigned software. And I should explain too. If this were to work, the client would go into Windows. I mean, it would be trivial for this to be added to Windows 10. Then, as we know, Microsoft never stops fussing with Windows 10. So it'd be easy for it to go there. So ultimately, this ought to be part of the base OS. the clients are just to sort of like get the ball rolling and get going.
And we're hoping somebody like LastPass might
build
it into LastPass. That'd make it very easy.
They've talked about that, and also the Chromium, the Chromium code base. So it could be built into Chromium rather than being an add-on as it is now.
Who has a question over here? Anybody? Yes. Wearing the Cal shirt. Are you from Cal?
I am also from Cal, yeah. Hi, Steve. So, quick question. I want to know, what does the support look like for like SSH? Any plans for those kind of like server direct authentication?
So no, I'm blissfully ignorant of the mess of the enterprise and everything that it needs. The good news is that this provides a verifiable identity, clean and simple. And so that could easily be the front end to whatever nightmare you're facing, like on your end, about which I know nothing, thank goodness.
Here's your pop socket. I forgot to give that. And Matt, I'm going to give you a pop socket too. All right, now we're going to get questions. Free pop sockets.
Yeah, but only 6.
What's your name? Brian, you're wearing a Computer History Museum t-shirt. Do you work there, or you just got it as a souvenir?
I just got it as a souvenir.
Nice. Go ahead.
Hi, Steve. Squirrel looks extremely promising, and I'd love to be able to use Squirrel to log in securely at work. Do you have any tips for how we might sell this to managers or to higher level people in order to kind of tell them what the benefits are both to the corporation and for the end user experience for their employees?
I saw your reaction when I looked at my phone and it logged me in.
Did he look like that woman in the slide?
Not quite as good, actually, but that's not your fault. So I mean, one thing you could do is just, have a phone and a laptop and say, hey, I want to show you something. This is free. It doesn't cost anything. It's open source. It's open spec. It's open protocol. It is, it's been carefully designed over the course of 5 years. Why not? And so just sort of, put the ball in their court. Show them what it is and give them a sense. And that may be enough.
It's kind of that's our job at this point, is to evangelize, because otherwise, there's your pop socket. If I were you, I wouldn't unwrap it. It probably is worth a lot of money at some day. Other questions? Yes.
Hi, Alice from Sacramento. So a thought that I had was with the rekeying, is there any thought of maybe making that proliferate through? So kind of maybe like a key server like we have with public keys, with signing software? Great question. I know the question so well because it's another battle that I've been waging. So for example, people have said, well, if I rekey, then I need to go visit the sites where I've used Squirrel in order to update those sites' knowledge of my new key. So shouldn't Squirrel save all of the sites that I log in at so that I can have a list of them to go back to? And okay, or someone said, well, I used an alt identity, but I forgot what it was. So shouldn't Squirrel save the list of alternate identities that I used with this site? And it's like, oh, okay. So my answer to that is, this is a minimal working solution. There are opportunities for people to extend it. One of the nice things about the fact that nothing changes as you use Squirrel is that means your 2 phones and your pad have nothing that they need to keep synchronized. One of the things, the service that we buy from LastPass is the cloud sync, which is how everything gets synchronized. So we could use, some future version could do the cloud sync model. My goal here was to sort of demonstrate that we can solve this problem without any cloud. And part of doing that is not changing the client in any way as we use it. Otherwise, immediately our devices get out of sync. This one knows that we logged in here, here, and here. This one knows that we logged in here and here. And how are we going to glue all that together? But great question, and believe me, it's been an issue.
Would you be more likely to use it if it were built into LastPass or Windows or iOS, or if it were part of the OS or part of a tool you use, you'd be much more likely to use it. And again, setting it up once, I love that.
Yeah.
Yes, sir. What's your name?
Hi, Eric from Sebastopol, just up north. Thinking about the analogies to Bitcoin, the consensus is like, well, Bitcoin has these problems, right? These implementation problems, but get excited about blockchain. That's the real invention. You mentioned a couple of extensions, and I was wondering, what are some of the sort of the non-username password applications that you're excited about? Like the ask functionality and there was the other one too.
Yeah. So ask is cool because it provides a feature that nothing else provides. A secure means for the site to ask the user directly a question outside the browser, which seems very useful because the browser is just so easily subverted, especially with any kind of man-in-the-middle attack. And then that idea of allowing Squirrel to provide a private key for server-side decryption of user-stored data. So that, like, there were all kinds of other, just sort of like, well, while we're here, let's add this, like form fill. So, they just didn't make the cut because there are already solutions for those things.
Anybody else? Yes.
So
pop sockets.
that's fine. No, yeah, I'm fine without a pop. I still haven't figured out why pop sockets are useful.
Yeah, nor have I.
So I agree with you that paper is a technology that's going to continue to be usable for a really long time. However, I have been noticing lately more and more that it is not a technology that is available to a lot of people. There's a lot of people with no printer.
Okay.
There's a lot of people who, if they do have a printer, don't have a connection between their printer and their phone, which is where they do all of the things. But I just recently FedExed 2 pieces of paper to Paris so that somebody could sign them and then take a picture of them with his phone and send the picture back to me. I won't go into why, but the reason why I had to do that is because he had no printer and no patience for even finding a printer. Somewhere in Paris there probably is one, but. And so it seems inevitable that a lot of people are going to store those 2 pieces of paper not on paper, and
Which is okay. It's
I just wonder
it's just then available. I mean, as we know, if it's in your computer, it's accessible from Russia, potentially. And that's not what you want here.
So do you think of that as just sort of, well, it's not any worse than what people are doing now where they're posting their passwords on their screen on a Post-it or something like that? Or,
Yeah, I think it's not any worse. I should note that I have no way of forcing somebody to print something. That is, nowhere is there where you have to hold the paper up to the camera and say, see, I printed it. But they have to be able to re-enter that rescue code. So they have to write down 24 digits. But the point is, we really need them to write that down so they have it somewhere. So they don't have to print it, but if they could, tattoo it if they wanted to.
Oh, please. That's less secure. Also harder to change. But you could put it in your LastPass vault. You could put, if you have a crypto vault, there's plenty of places you could put it that would be more secure than your boot.
Yeah.
So,
or like put it in an encrypted zip file. I mean, just because then it is still encrypted.
It's encrypted.
Yeah. I just love being an absolutist. I just don't put it in your computer anywhere.
Right.
But
No,
if you do, it's not the end of the world, as you say.
Any questions in the back here? You sat in the back, so you didn't have to get questions. But go ahead.
Thanks, Steve. I was just wondering, maybe you hit on this and I missed it. If we have multiple devices out there and we wind up doing the rekey, do we need to do that to each device, or how does that work?
You did not miss it. Good point. Great question. The question was, I guess you heard because of the microphone, multiple devices and you need to rekey. We have a provision for detecting if you attempt to use a device that wasn't rekeyed. So servers maintain a list of all of the retired keys they've ever seen to specifically to say to someone who might be trying to use an old key as their new key, as their current key, whoops, you must have rekeyed on some other device and forgotten to copy the identity over. So to answer your question, there is, again, no cloud sync, no magic way. So when you rekey in one location, you're able to display your identity as a QR code. I'll show you here. Backup, export identity, display it as a QR code, store in a file, print the identity, and so there is the identity. And so I just let my phone see that, and I'm transferred.
So you screenshot that, put that in LastPass.
Exactly.
Yeah.
Yes.
Yeah. If anybody has a burning question, because we're going to
we're adjourning, right?
Yeah. But go ahead. It's not burning. You gave up. Yeah. By the way, Retcon 6. Go ahead.
No.
No.
Retcon 5 normally. But back to the evangelizing portion and the future. And thanks for the presentation and all the work. What would you expect or hope if you had a wish of the next steps? Like, have you had buy-in? Have you reached out to large companies that may be the next people to adopt something like this? Like developers, GitHub?
So I gave a presentation to Stina and her engineers at Yubico, and they loved it. I had an answer for every single question. And they've no identity, and it's like, oh yeah, I'll get there. I mean, so I nailed it for them. They have indicated an interest and a willingness, if there's a market, for a Squirrel version of the YubiKey.
So they do TOTP now in a YubiKey. Could they do Squirrel?
Yes.
So it's not that computationally.
It's not.
intensive.
And because the elliptic curve, the reason we've switched to it is it's so much faster and so much lower computation,
Right.
and the crypto chip they're using has programmable curves in it.
Nice.
And so the idea would be that your identity would be in here and it never comes out. You put the data in and out comes a signature, but never the key. It's never exposed. So, then we've got like really robust identity.
Very nice. Thank you, Steve.
Hey,
Appreciate it.
thank you very
Steve
much.
Gibson, a host of Security Now every Tuesday on the TWiT network, 1:30 Pacific, 4:30 Eastern, 21:30 UTC. Subscribe at twit.tv/SN or go to his site, grc.com, because that's where he's got SpinRite. Where he's, by the way, now that this is done, 6.1?
Yes, honey.
Now that this is done, 6.1, and if you buy 6.0 now, you'll get 6.1 as soon as it comes out. grc.com. You can also get his Security Now show, and this show will end up being. Are you going to do a 16 kilobit version of this?
Well, I guess so.
You might as well. Why not? No slides in that
We'll turn
one.
Elaine loose.
Yeah. And she'll do a transcription.
Yeah.
That would be actually very, very handy. So look for that at grc.com. Steve's also on Twitter at SGGRC. He takes direct messages there. So if you have a question about Squirrel, that's a good place to ask him. At SGGRC on Twitter. I'm Leo Laporte. Thank you all for being here, and thank you for joining us in this very special TWiT event.
Opportunity available.
It's our first TWiT event.
See you on Tuesday.
In the new feed. See you Tuesday.